The V8 engine, 8 cylinders, hundreds of moving parts, and one of the most iconic power plants ever engineered. But how does it actually work?
Found in everything from classic muscle cars to modern trucks, the V8 has dominated automotive performance for nearly a century.
To understand how it works, we need to look inside. Let's strip away the exterior and examine every component one by one.
The foundation is the engine block. 8 cylinders are arranged in 2 banks of 4, forming a V shape, typically at a 90-degree angle. Each cylinder is a precisely machined tube, bored to exact tolerances measured in thousandths of an inch. This is where combustion happens. Inside each cylinder sits a piston, a flat-topped metal disc that slides up and down with incredible precision, sealed by thin metal rings. The piston rings create an airtight seal against the cylinder wall. This seal is critical. It traps the explosive force of combustion above the piston. Below the pistons lies the crankshaft, a heavy forged steel shaft with precisely offset sections called journals. This is where linear motion becomes rotation. As each piston is pushed down, it drives the connecting rod, which turns the crankshaft. Up and down motion is converted into the rotational force that ultimately spins the wheels. With 8 pistons firing in a carefully timed sequence, the crankshaft receives a power stroke every 90 degrees of rotation, delivering remarkably smooth, continuous power. Sitting on top of the block are the cylinder heads. These seal each cylinder from above and house the valves that control the flow of air and fuel. Each cylinder has at least 2 valves, an intake valve that lets the air-fuel mixture in and an exhaust valve that lets the burned gases out. When the intake valve opens, a precisely measured mixture of air and fuel rushes into the cylinder, drawn in by the downward movement of the piston below. The valves are opened by the camshaft, a rotating shaft with egg-shaped lobes. As each lobe rotates, it pushes the valve open at exactly the right moment. The camshaft is connected to the crankshaft by a timing chain. This ensures the valves open and close in perfect synchronization with the pistons. Timing is everything.
Now let's see how everything works together in the 4-stroke cycle, the sequence that repeats thousands of times per minute inside every cylinder.
Stroke 1. Intake. The piston moves down, the intake valve opens, and a precise mixture of air and atomized fuel is drawn into the cylinder. Stroke 2. Compression. Both valves close and the piston rises, compressing the mixture to roughly 1/10 of its original volume. The pressure builds dramatically. Stroke 3. Power. The spark plug fires, igniting the compressed mixture. The explosion generates temperatures over 2,000 degrees, forcing the piston down with tremendous force. Stroke 4. Exhaust. The piston rises again, the exhaust valve opens, and the burned gases are pushed out of the cylinder. Then the cycle begins again.
Now multiply this across all 8 cylinders, each firing at a different time, and you get the smooth, continuous power that defines the V8.
Modern V8 engines use electronic fuel injection. Injectors spray a precisely metered mist of fuel into each cylinder, controlled by the engine computer dozens of times per second. The spark plug delivers up to 40,000 volts across a tiny gap, creating a spark that ignites the mixture in a fraction of a millisecond. Timing this spark precisely is critical to performance. The cylinders don't fire in numerical order. They follow a specific firing order designed to balance the forces across the crankshaft and minimize vibration. The crankshaft includes heavy counterweights that balance the forces generated by each piston stroke. This is why a V8 runs so much smoother than engines with fewer cylinders. With hundreds of metal parts moving at high speed, lubrication is vital. The oil system pumps oil through channels in the block, reaching every bearing, every journal, and every moving surface. A thin film of oil, just thousandths of an inch thick, separates every moving metal surface. Without it, the engine would destroy itself in seconds. Combustion generates extreme heat. A network of coolant passages runs throughout the block and heads, carrying a water and antifreeze mixture that absorbs and removes that heat. The heated coolant flows to the radiator, where it passes through thin tubes surrounded by aluminum fins. Air flowing through the fins cools the liquid before it returns to the engine. After combustion, the spent gases exit through the exhaust valves into the exhaust manifolds, one on each side of the V. Temperatures here can exceed 1,500 degrees. The exhaust flows through the catalytic converter, where precious metals trigger chemical reactions that convert harmful pollutants into less toxic gases before they exit the tailpipe. When you press the accelerator, the throttle opens wider, allowing more air into the engine. More air means more fuel, bigger explosions, and more power. At 6,000 RPM, the crankshaft completes 100 rotations per second. Each piston travels up and down 200 times per second. The precision required is extraordinary. The engine also powers auxiliary systems through the serpentine belt, the alternator for electricity, the water pump for cooling, and the air conditioning compressor. At the rear of the crankshaft sits the flywheel, a heavy disc that stores rotational energy and smooths out the gaps between power strokes, keeping the engine running evenly. From explosion to wheel spin, the power path flows from piston to connecting rod to crankshaft to flywheel and finally into the transmission, which delivers that force to the wheels. Compared to a four-cylinder engine, the V8 fires twice as often per revolution. This means more power, more torque, and a much smoother delivery of energy. Some V8 engines use forced induction. A supercharger driven by the engine's own belt compresses incoming air, cramming more oxygen into each cylinder for significantly more power. The engine control unit, the ECU, is the brain. It reads data from dozens of sensors and adjusts fuel injection, ignition timing, and valve timing thousands of times per second. Some modern V8s can shut down half their cylinders during light driving. Cylinder deactivation saves fuel by running on just 4 cylinders when full power isn't needed.
Even at idle, hundreds of components work in perfect harmony. Oil flows, coolant circulates, valves open and close, and each spark fires at exactly the right microsecond.
What appears on the outside as a simple metal block is in reality one of the most refined mechanical systems ever mass-produced. The 1955 Chevy small block changed everything. Compact, lightweight, and powerful, it set the template that V8 engine designers still follow today. A typical V8 from the 60s produced around 200 horsepower. Today's V8 engines deliver over 700 horsepower while using less fuel and producing far fewer emissions.
The result? Raw, smooth, reliable power. The V8 engine remains one of engineering's greatest achievements, turning controlled explosions into the force that moves the world.
8 cylinders, 4 strokes, one masterpiece of mechanical engineering. That is how a V8 engine works.